Hello, and welcome to the Fortify Mold Tools Tech Talk. My name is Ben McDonald. I'm an applications engineer here at Fortify. I focus on everything from designing injection molds all the way through actually processing those injection molds. And today I'm joined by James Grimm from the Empire Group, who's going to speak a little bit later on their actual use case by printer. Do you want to say hello, James?
Hey everyone, I'm James Grimm. I'm the lead business development manager at Empire Group, helping all of our customers with manufacturing solutions.
All righty. So today we're going to do a brief review of the Fortify technology, followed by highlighting some of the key tools we use to refine our molding process. From there, we're going to transition into how we help our customers succeed. And that's when we'll let James go ahead and introduce Empire and share a little bit about their story. And then finally, we're going to give everyone an easy path forward to satisfy whatever their needs are, whether that be the molding of one-off parts or bring this technology in-house so that they can become experts of their own. So to get started, why 3D printed tooling? Well, there's really two key reasons why someone would want to use 3D printed tooling over traditional injection mold tooling. The first one would be having molded parts in 3 to 6 days as opposed to 3 to 6 weeks. The other reason being mold cost at $300 to $600 as opposed to $3,000 to $6,000. So these are really two huge reasons why someone would want to use this technology. And it's really a great practical solution for prototyping and end-use materials, quickly iterating on complex designs, and even in the right circumstances, doing low-volume production runs. So what makes Fortify unique? And it's really simple. It's fiber reinforcement. So just like the traditional injection molding industry introduced fiber into their polymers in order to get improvements in material properties, Fortify has done the same thing. We use our continuous kinetic mixing module and our flux print module, which allow us to both suspend and align fibers in our parts. And this really allows us to get a jump in material properties that ultimately gives us a performance boost for injection molding. So we'll take a look at a real life use case here. On the left side, we have a Fortify 3D printed tool with our fiber reinforcement. And you can see after 100 shots, the tool looks great and still running strong. On the right-hand side, we have a competitive 3D printed tool that really, it didn't go well. I mean, after the first handful of shots, you're seeing feature failures all across the mold. There's really all these different features are seeing failures after a handful of shots. So on top of that, we've run some tests between the Fortify tools and other, competitive tools. And really, we see that there's feature failures almost from the get-go on these competitive tools. While with a Fortify tool, we run 50 parts as kind of our benchmark number. We didn't see any failures. Beyond that, Fortify, we're able to run, faster cycle times, and we're able to hold better tolerances both on the printed mold and on the parts themselves. So one key thing is the massive variability of a part, and that's going to tell you how much from shot to shot a part kind of deviates. And we see that Fortify tools have the lowest mass variability across this run compared to all these other technologies. So what really makes Fortify unique is our application focus on injection molding. We try to take an end-to-end process for actually running these injection molds. And that starts with tool design, where we'll look at things like gating, venting, using inserts, hand loads, all sorts of stuff like that. From there, we'll print our parts, and then we get into our modified molding process. And that's really all about controlling the injection phase, so low pressures, slow speeds. Then we run with lower pack pressures and longer hold times. And all of these things we bundle together, and that's our Fortify mold process that allows customers to really maximize what they can do with these injection mold tools. Coupled with that, we have an in-house mold press at our Boston HQ, which is really something that across the industry you don't see. We use this press both to run customer projects and to run focused development projects. So everything from a potential customer that might want to bring our technology in-house, all the way through trying to improve on our materials and improve on kind of the boundaries of what these Fortify tools could do. So we'll go ahead and highlight one of these tools here. This is our torture test mold, our internal test mold. We use this mold to really refine processing conditions and best settings for each material. So our goal is to run 50 plus shots with whatever the plastic of choice might be, whether that's polypropylene, nylon, polycarbonate. And we'll take this tool and we'll look at what features fail. So it could be high aspect ratio pins, a shutoff feature, closed space ribs, blind pocket holes, or even this fine knurling pattern we have. And we characterize those failures and we build on that knowledge. And that really allows us to iterate on this design and get to a point where we are running these polycarbonate tools with no failures. So talking about this is all great, but we also love to share our knowledge in other methods. So we have our best practices guide, and that's really a free reference on our website that covers some of the top questions we typically get asked. So everything from design tips to expected shot counts, all the way through really getting deep into the Fortify molding process. If you've gone through that and you're interested further, we have our Fortify onboarding training program. That's where we work hand in hand with customers in 2 projects, and we go through everything from setting expectations for the proper use cases for this technology, all the way through collaborating on tool design, mold frame setup, and even running the press. So whether that's at our Fortify HQ or at the customer site. With that, I'll turn it over to you, James.
Thanks, Ben. Just really quick here, I'll kind of reintroduce myself and introduce the Empire Group for you to everyone here, and then also just talk about how Empire has partnered with Fortify through the onboarding program. I'll talk a little bit about our experience there, the successes, and then also get into where we're going in the future with Fortify rapid injection molding. So just real quick here, Empire Group is an East Coast-based design and manufacturing company. We specialize in everything from engineering design into 3D printing, prototyping, models, and then getting into low volume production as well. So we use a number of technologies, and we have all of these things under one roof at our facility in Southern Massachusetts. So we get into things like 3D printing, mold and cast, CNC machining, injection molding, and really just world-class part finishing and model making as well. Many of our customers span the breadth of consumer products, from medical devices, consumer goods, consumer electronics, and even into things like Department of Defense contracting, and like high-speed, high-performance automotive applications as well. So we've got a really wide breadth of customers that we service. So let's get into a little bit about our experience with Fortify's onboarding process. So we went through the onboarding process with Fortify, which was really great. I mean, honestly, we kicked this off in the fall of last year. Fortify was very hands-on through 2 molding projects and helped train our engineers on how to do mold design for this using this application of 3D printed tooling. Worked with us on teaching us how to run the press, and really gave us the confidence to launch this as a full-scale product at Empire. Our goal here was to get hands-on experience with real tools and real customers' parts. So we were able to use one of our customers to pilot this program with Fortify. And so it was a really great experience. It wasn't made up experience. We used actual customer components to test it. And the whole process actually went really well. We delivered the final injection molded parts to our customer with rave reviews. They were super excited and they couldn't believe that these parts came off of a 3D printed tool. So all in all, the onboarding process was extremely successful, and Empire is ready to take the next step with our customers. So just kind of looking into what that's going to be, right? So Empire is launching a turnkey rapid injection molding product offering. So this is where a customer can simply supply your 3D part data to Empire. Empire is going to take it from there. So we're going to design the tool, we're going to build that tool, and we're going to shoot the parts. And the sort of promise here is, we want to have our customers, as an example, right? You submit your part data on a Monday. We design that tool, start shooting parts that week, and deliver you injection molded parts the following week, right? So this sort of 1 week turnaround time from you submitting your part data, us designing a tool, shooting the parts, and then delivering the injection molded parts. This is really an incredible offering. It's a really ambitious goal. And with the Fortify team's help and this new technology, we're right there. So we're really excited to get this into the marketplace.
It's really great stuff, James. So next steps, maybe you want to get some one-off injection molding parts. And if that sounds like you, please reach out to Empire. You want to work with the Empire Group. They're perfect for when you have regular project needs and no in-house molding capabilities. And from our experience, they do great work. Maybe you're interested in the Fortify technology. You might want to bring a printer in-house, or you have molding capabilities and you have a high volume of projects, so 2, 3, 4 projects a month. In that case, please reach out to Fortify and we'll get you started with an onboarding program and well on your way to getting your own printer in-house. Thank you, everyone.
Yeah, thanks, everyone.